Hello, welcome. I am going to, as many requests have come in with help for problem number 19.28, I'm going to show you how to do it and walk you through it, okay? So here it is. I have it out right now, and it is definitely a Kirchoffs Law problem because we have two battery sources, so we are going to use them. And then we have a couple problems, right? They want to figure out the currents of 1, 2, and 3. Then they want us to figure out the left, what the directions are. And then it actually throws in internal resistance, and we kind of have to do the problem again. So I anticipate I can get through the first part in one video and then the second part in another video. So let's go ahead and solve this. So what I did is just copy and pasted the information into this, blank space right here. So let me just get myself set up. There we go. Oops, sorry. Okay, so hopefully you can hear me over here. But we're going to use Kirchoffs laws. So remember, we need to, when we do this, this is the order I do it in. Number one, draw the direction of the current. And you choose that direction. Remember, you can pick it however you like. If you choose the wrong direction, it's fine. You'll find out in the end when your answer is negative. That's all that means. So don't worry about it. So let's do that. So I'll draw the currents in blue because I can. So here's a node right here. This is when, three currents can, come together. So I'm going to choose the direction of current 1 to go like this, I1. And again, that's this whole loop right here. And then, as always, I try to be consistent. I'm going to make I3 go down like this. And then I'm going to make I2 go like this. And then from the direction of my currents, I can create the equation for conservation of charge, which says that current 1, the in current, must equal the out current. I2 plus I1. Like that. So that's our first equation we're going to be using to help us solve it. Next, after I do all my currents and choose their directions, I'm going to draw my loops to apply the second Kirchhoff law, which says that the sum of the voltages must equal to 0. So we're going to look at the voltage drops, if you will, between that. So I'll put let's do that. Let's do them in red because we can. So that's my first loop clockwise this way, and undo the second loop clockwise this way. So when I'm analyzing these loops, I've memorized those conditions. So just kind of reviewing those conditions. Remember, when the current is going, when your loop, this is your loop, okay? If your battery is facing this way when you're going with your loop, that is a positive voltage. But if your battery is facing the other way, like this, that's a negative voltage. So these are things you have to memorize. This is where I'm getting it from. Otherwise, you can't do the problems. So when you get to resistor, same thing. This is the direction of my loop. You have to look at the direction of the current through that resistor. So if the current, I, is going the same direction, that's losing energy. So that's minus IR. And then, of course, there's going to be a resistor going through this current like that. And then if it's the other way, if your current's going the opposite way of the loop, you're gaining energy. So it's going to be positive IR. So that's just another note because you're probably wondering where I'm getting this from. I'm getting my designation of voltages from this conditions, or these conditions. So let's go ahead. I'm going to box this because we're going to use this later. And let's do loop 1. I'll just call this 1, 2, just for sake of labeling. So loop 1, the top one. All right, I'll start with this resistor. My current I2 is going with the loop right here. So if you notice, when you have with, that's a negative. So what I have is minus I2 times the resistance of R2, which happens to be 61. I get that from the problem. 61. And I usually leave out the units when I'm doing this just because it's overwhelming. So I just leave it as the number 61. All right, so then as I go through like this, I get to the first EMF or battery, and I'm going from the negative to positive side. So that's an additive voltage, and E1 is 9 volts, so I'm going to add 9 volts there, like that. As I go, my loop is going with the current and through R1, so then I have minus again, because it's going with the current. We don't want that. Let's do, R1 is what? Here we go, 24. And now that we're done with this loop, let me set that to 0. Okay, same process, loop 2. Here we go. So we do it like this. So there's our loop. I'll start this battery. I'm going from the positive to the negative, so I lost energy here. So that's going to be minus 12, that's E2. And then as I go through over here, I'm going against the current, so I'm actually going to be adding this time my loop, that is. See, my loop down here is going against the current. So I'm going to be adding I2 and its resistor, which was 61. Yes, 61. And then my loop goes with the current here, so that's a negative. So minus I3, R3, which is 31. We'll get that from the problem too. And then once we're all done, we set it equal to 0. So there's our major equations. This is the physics part. So this is, if you could get here, I'm pretty happy with this. And like I said on our exam, I want you to be able to do this as a multiple choice. So if you're solving your homework problem, here's how we're going to keep going, okay? Now, again, you don't have to use the matrix method. You can actually solve this by doing 3 times substitution. It's grunt work. It does work. So you can plug I1 into here and then plug I2 into here and have everything in terms of I3. Like, you can do that. That works. But like I said, it can be challenging. So here's what I'm going to do is I'm going to rewrite all these equations, 1, 2, 3, if you will, in my matrix form, right? So I know some of you are using the matrix form, so here it is. This is how I set it up. And sometimes I even put the equal sign there. And then, I don't know, you put the number right here. So remember, this is going to be a 3 by 3 right here. And then this is going to be just numbers. So what I'm going to do is put this, basically categorize this. So write this. I can write it to this side, I suppose, in terms of I1, I2. So I'm just going to rearrange the equation so it looks like this format. So if I do that, notice if I bring I2 over and I3 over, I have it in the format I1, I2, I3. And then remember, I'm taking the coefficients. So coefficient for this one is positive 1, then it's minus 1, minus 1. Since there's no coefficient, we could just say 1. That's what I'm doing here. And then after the equal sign, the 0 goes here. Same thing, I'm just going to rewrite this in that order. So I'm going to put I1 first. So minus 24 I1. I'm going to write I2 next. Minus 61 I2. There's no I3, so we put a 0 for a placeholder. And then it's positive on this side, and I need to bring it over to the other side of the equation. So this should be negative 9 over here, like that. So that's our next equation. So then we get negative 24 minus 61, 0, minus 9, like that. I always make too much room. And then same thing, I'm just going to go ahead and do it since I assume you know what I'm doing. So there's no I1, so that's 0. I got a positive 61 I2 here, minus 31 I3 here, and I need to bring the 12 over, which makes it positive. 0, 61, negative 31, 12. Okay, so that's the matrix idea. And then what I'm going to do is, like I said, I'm going to use my calculator to do this. I don't know if there's any online sites. I could probably look into that, but you set matrix A as a 3 by 3. You're going to edit it for the numbers. You're going to set it to -1. and then do matrix B times matrix B, which is this one. So this is matrix A, and this is matrix B, like that. And then if you do this, you will pop out the following answer. 0.0234, 0.138, and then negative 0.114, like that. So what this answer represents, by the way, when you do this, you get the currents in order, I1, I2, and I3. So by doing that, that's what we have here. So this one is I1, this one is I2, and this one is I3. But notice I3 is negative. What it means is that we actually chose the wrong direction. So I have it drawn right now that I3 is going down, when actually it should be, why not? Let's erase it. It's wrong. It's going up. That's what the negative means. So, like this. So actually, technically, these two go in and that goes out. But we don't need to do anything now. We've already solved the problem, so it's not a big deal. So if you notice, the following question is, what's the direction of the current? So notice through R1, this current is definitely going to the right. I2 is left, you can see that there. And then lastly, I3 is up. So let me see how much time I have left on this video. Can't tell. Oop, 12. Okay. All right. So I'll stop here because that's a good stopping point for this problem. And what I'll do in the next video is solve the next part, which is the internal resistance. It's actually not that bad. It's just, unfortunately, you kind of have to redo the problem. But I'll show you how that looks in a second.